let me start. So this is a DFKI perspective. I'll talk a little bit to the end of our concrete work that we're doing, but also we'll give an overview of some of the initiatives that are happening. Bernard just talked a little bit about DFKI, maybe a little bit more detail here. As far as we understand, we're still the largest independent AI research center worldwide, 34 years in operation. By now, a number of sites, 4 main sites in Germany, Berlin, Darmstadt are being added to that, 24 research areas, 9 cross-cutting competence centers for deep learning, for autonomous driving, for examples, and also large demonstration centers that we're operating. More than 1,400 people working on this, and we're growing quickly. And I'll talk about some of the consequences of that. Startups are really a key part of what we're trying to do. We're an application-oriented research institute, but because AI is working so quickly, and it's advancing so quickly, we actually have to do a lot of the basic research as well, which is a lot of fun, of course. All of our scientific directors, by the way, are professors at the local universities. So we have a very, very close collaboration between the universities and the other institutes at the local sites with the DFKI. So I think that is working really well. Also, we are a private organization, a non-profit company under German law, focused only on research. Our shareholders are mainly industry, big companies like Intel, Microsoft, SAP, many others, automotive industry, financial insurance industry, agriculture, you name it. But besides all of the research we're doing, and I'll talk about this a little bit later, a big focus as the German Research Center for AI is also like creating synergies and linking things across various scales that starts locally here, in this case in Saarland, with the Max Planck Institutes on campus, with the university. We have a Helmholtz Center and other centers where a lot of AI activities are taking place. We operate and we strongly support the regional collaboration. We're located right on the French border near Luxembourg, so kind of in the center of Europe, which is great. So we have close collaboration. We're just setting up a center, a transfer lab with the Luxembourg Institute of Health, for example, using AI technology in that area. We're involved with the university there. We have very deep connections with the INRIA in Nancy, the INRIA lab in Nancy. Also nationally, there's a strong collaboration between DFKI as a national institute and INRIA within Germany, various activities. And we're a key partner in many of the European activities, like these networks of AI excellence centers in Taylor. We heard about Taylor yesterday, the Vision, the Humane AI Net, and others. And I'm one of the co-founders of the European Confederation of Labs for AI Research in Europe, CLAIR, which I come back to later, and we're involved in some of the international activities. And just because we're here in France, I just wanted to highlight the collaboration with INRIA. We're investing from the DFKI side, 6 million into a number of projects, 5 projects, you see them here. We have regular weekly meetings, coordination meetings with INRIA. We're organizing summer schools every year, so for the second time now. And actually, one of the ideas that came up here is maybe we should take Trusted in Confiance.ai as one of the key topics for next year. We're actually currently planning the summer school for next year. Workshops and European activities with France, with INRIA. And the same amount of investment is roughly from the French side as well. So there's a lot of collaboration here, and I'm very happy that we are talking about more collaboration going forward here between Germany and France. So let me talk a little bit high level about Trusted AI, our kind of view on that topic, and then dive into a little bit more research afterwards. So if we step back a little bit, what is it that is required to be able to develop trust in technology? And if you think of that in a larger scale, there's essentially two main ingredients that you need to have. There's other stuff, but here from a technical point of view, right, there's either the deductive way, you have a theory about that, and from that theory you can derive properties of a system, and you can base that trust on these guaranteed properties of the system, right? But that requires a theory. The other one is the inductive way, where, right, if you just test enough, that is another way of doing this. And actually, we've been doing this for hundreds of years, right? We didn't just build big cathedrals by putting stones on top of each other and hoping they don't fall down, but we actually built small models of cathedrals. We put sacks of sand on top of them. That was an inductive testing approach, and it's been quite successful, as we can see also here in France and other places. Really great cathedrals that were built that way without any theory by the time, right? And since Newton, of course, we have, right, and many other people, of course, we have theories, we can derive properties if we do have a theory. And I mean, there's funny things, right? The steam engine was built and widely operated, and the theory of thermodynamics was actually invented about 100 years later. So, right, we can do a lot of stuff without theory, with testing, and the TÜV and other assessment organizations have essentially been built around that. So if we now think about what is it in computer science and IT technology, right, testing is really the majority of the approaches. We have some theory, we can prove certain properties. It's not as widely used as maybe we, certainly as academics, would wish to because of the effort involved here. But now if you look at the AI side of things, right, at least for certain parts of AI, specifically deep learning and others, we don't really have a good theory. There's starting points for that, but rather limited at this point. And testing is really hard because the context of what needs to be tested is very limited, which makes it really hard to have a basis for providing any sort of guarantees which can then serve as the basis for trust. Also as a basis for explainability methods to build on top, right? Because explainability needs to be grounded in properties of a system. So that's essentially the context that we're operating in. And so what we need to be doing, and of course there's a lot more detail that I could talk about, but in summary, there's two main things that from our perspective we need to be doing. And the one is, I always say, from the AI that we will have in 20 or 30 years, we probably know way less than 10% of that now, right? So one key element is push. What can we do with AI? Invent new AI methods, and ideally these AI methods will already provide guarantees by design, by the design of the methods themselves. And the other direction, kind of orthogonal to that, is to increase control, to provide more control over the AI system, to be able to provide guarantees if they are not built in, provide other sort of guarantees by, for example, tools. And in that way, increase that green area, right, of the known AI technology that's also safe to operate, for which we can provide guarantees and things like that. And this is really, and I think a lot of other people already talked about that, that's really something where we in Europe are very well established to do that for a number of reasons, right? On the political side, right, we have really a strong, in our societies, in the political systems, a strong focus on these topics, on the economic policy as well. We have a very strong interest on the industry side. We see this everywhere, certification, quality, right, made in Germany, made in Europe, is really a key selling point for our industry. So quality leadership and high innovation is certainly something we're really strong at. And we have really good research, on the other hand, right, scientific excellence and a strong AI research community. And bringing these things together is really key to make changes, and that has happened here in France, and we're trying to make that happen more broadly in Germany as well. And I think we also need to bring this together across Europe, And the CLARE initiative that I co-founded is, and that's strongly supported by INRIA, by DFKI, and many other European research centers and organizations and labs. So we have more than 440 labs members of CLARE. So I think we also have now the infrastructure that can serve to take the results that we're developing in the different initiatives here on the national level and bring them forward on the European level. And I think that's something we should focus on going forward. Let me talk a little bit about the German initiative that is we've put together. There's a core group of founding organizations. You see some of the industry members here, and that's really trying the value proposition that we're trying to get across here is right that we want to move from that traditional value-oriented German industry. Right, the gap size is sometimes used in the automotive industry as like the quality metric of good German cars, and translate that that kind of value that we've been building on for hundreds of years, and translate that into that new era of AI, of hopefully trusted AI, and the same values like quality, ambition, diligence, pride, and so on. All of them play the very similar role in AI, right? And so translating the more traditional paradigms like precision, reliability, safety, durability, translate them over into the corresponding aspects on the AI side. And this is a German initiative here. We have a number. You saw some of the projects that actually are paying into this here, and I'll talk about some more. We've been, as DFKI, we've been involved in many of them. By the way, DFKI, I should mention, at every point in time, we do more than 400 projects are running, and 80% of those projects are together with industry, at least one, typically more industry partners are part of that. So we are really deeply engaged with the German, mostly German industry, but also on the European side. And right, bringing the French initiative here, Confiance.ai, together with what we're doing on the German side, I think is, and then jointly push that towards Europe, is something that I think we should engage in the future. So I don't have much time to go into details here, but one of the key elements of the initiative is at the core start with 4 key technologies on the AI side. I already mentioned that advanced AI develop AI methods that provide guarantees by design from the methods themselves. Obviously, we're very much at the beginning there. If we don't have methods that provide these guarantees by design, we need to develop tools. Verification, validation, testing are key elements here for external tools that provide some sort of guarantees about an AI system, right? And they also provide the basis, the grounding for being able to do explanations, right? If you don't know what your system guarantees, it's very hard to argue and to explain what the system is doing. You need some grounding for that. And so the next step, obviously, is the human understanding, explainability, causality. We talked about this yesterday a lot here. But it needs to have a good grounding, and where we don't, and where we develop them, that's where really now explainability comes. And that enables us to do argue towards certification and things like that. And another aspect that was mentioned multiple times at this event here is really interactive AI, the safe human AI interaction, both in terms of the human understanding what he or she can expect from the AI system. So really have a theory of mind in some sense for the human to understand what to expect from an AI system, but also vice versa, to have a theory of mind for the AI system to understand what are the intentions of the user and really understand where the user is coming from. But this also involves like the learning from each side, from the other, right? I mean, learning, whether that's imitation learning or other learning, interactive learning. We talked about interactive explanations, for example. So all of these things are a key element in order to be able to develop trust, right? You need to provide the guarantees, but then you also need to provide the interface to be able to be convinced that the system actually is trustworthy and provides, it actually in its operation provides all the things that is needed. And around this there's also the safety community where we go from single systems to multiple systems, guaranteeing cooperative behavior and on large-scale system of systems, talk about these aspects, identifying operational domains, safety cases, and many other things. So we've also started to bring together the safety community and the AI community, which traditionally haven't really talked that much with each other, and we're trying to approach that. And in that context, we are actually, I can announce, I don't have a slide for that, but I can quickly announce this here. We now, in the last weeks, we got confirmation to set up a center for European research on trusted AI that is being set up in Saarbrücken on campus with DFKI, with the Max Planck Institute and others. And we're already setting up the connections to INRIA and OSCE on the regional level, but we'd love to set up connections to many other places as well. So expect some more announcements in the coming weeks about that. But so with that background, let me talk a little bit of what is the research that we're doing in this context. And one of the key elements that we're doing is digital reality. And let me just quickly give you a glimpse of what we're doing. It's really a large program that we're addressing, also from my group, which is called Agent and Simulated Reality, one of these research areas in DFKI, with this focus in the center of trusted AI, developing explainable and trusted AI methods, digital reality, and HPC. So this is really which comes together here. Also with my background, I'm a physicist by training. I'm a professor for computer graphics at Saarland University, and I'm a scientific director on the AI side. So really integrating these areas, and we're doing a lot of high-performance computing to make all of this run efficiently and reliably. So, but I want to focus on this digital reality aspect here in the top right. So how can we use synthetic data for training, validation, and hopefully certification of AI systems? And this whole diagram starts here in the lower left-hand corner from reality, from using AI methods to learn models about reality, partial models about reality for certain aspects of reality. And then we can take those models and put them together to model certain scenarios. We heard about humans on the track in the train scenario. We are working a lot in the car context, and one of the key elements that I like to explain things with is, and that's similar to what you mentioned, right? A kid running in front of a car, right? Initially, the car industry thought about, how many millions of kilometers do we have to drive to have a safe autonomous car? It turns out that's a really bad idea of designing an AI system, because that essentially means how long do I have to drive until I hit enough kids so I have enough data to prevent it in the future. And I think we all agree that is probably not how we should develop AI systems. So the idea here is with those models, with models of motion and behavior of pedestrians, we can model those scenarios. We can then, and that's the second step here at the top, we can reason about which in these large parameter spaces, which areas are critical that we need to focus on, right? Like kid running in front of a car. And then we need to instantiate, we need to sample in these large spaces all of the variations of the scenario kid running in front of a car, different kids from left, from right, at night, at day, with fog and different clothing and many other cases. So then we have these different scenarios, and then the third step, we need to simulate this, not just the scenario itself, how the kid runs across the street, but also the sensors. We need to, so that we can generate the data that a real car with its real sensors would be, what that AI system or that car would see if it were in that scenario, right? And then we can use that to kind of drive training, validation, and certification, and hopefully achieve trusted AI that way. And one thing that a lot of people are missing is that we need to close that loop, right? Once we have that AI system, we also need to go back and see how does that actually perform in reality. How do we identify where our models might not have been perfect, but also if our models were perfect, we still have to do that because reality changes over time, right? So we have to do that anyway, key element here. And I explained this all in the context of autonomous driving, but all of that works as long as you can model the environment that the AI system interacts with. And so we're doing this in many other contexts as well. And I have a couple of slides looking at some of the research. So for example, here we do a lot of work with pedestrians, and this is being transferred also to industry already. Here's, for example, the case that we studied where pedestrians that look behind them behave very differently if the looking behind is about, well, looking for the bus, whether the bus is coming, you have to start running to catch it, or whether you look behind yourself because you want to cross the street, and it turns out if you want to cross the street, you are actually starting to turn your body already, very slightly, very subtle, very hard to detect, but we can detect it, we can measure it, and we can generate that. A key element here is, yes, so I have to stop shortly. So motion synthesis, how do we create models of pedestrians in situated environment, also model the intention of these users, and enrich that. We're actually, so here's an example of a project we're just about to finish where we studied pedestrians in Germany. We now did the same thing in Japan, and there's very interesting differences, a really cross-cultural study here, and there is actually discussion already ongoing. We should do that also in France, and maybe other places as well. Really interesting results out of that. Here you see some of the examples where we did this in a virtual environment, so we can safely really also study critical scenarios. Very interesting work. An agent framework, so we can reduce the number of parameters by having high-level control of the pedestrians using multi-agent systems, but also use imitation learning to get those agents to behave like real humans would behave in certain environments, and the cross-cultural study informs us of how we should model that. We're doing very interesting research on hybrid learning and planning. There's the HighLeap architecture, for example, where we combine learning for planning, and we're currently have very nice initial results for actually combining it the other way around. So we're studying how can we, what we call neuro-explicit models, how can we really combine neural methods with as much as possible explicit knowledge that we might have, and how can we, and there's different ways of how to combine that. More on the simulation side, and that's kind of towards the end of what I want to talk about. We did very nice work on advanced radar simulation code. This is very briefly, and I don't have time to go into this, but this is the state of the art before we started our research. You see in the lower left-hand corner what it should look like, and with our new technology, Monte Carlo simulation code, we're getting really, really close to that. And we can do simulations here in a couple of seconds, which commercial software uses 13 hours to get, and it doesn't get it right either. It's longer and it's worse, so quite interesting. And so I want to stop with one key aspect, which I think we've talked about, is this challenge, verification and validation, formal methods and testing approaches. Verification is pretty much a top-down method, right? Where you start with a formal description here, but typically we have to fight with limited expressiveness and complexity. And on the other hand, we have validation testing methods, right? Very rich, very flexible models, as I just talked about, but we cannot guarantee completeness, and we only get statistical results. And so these two areas have typically not talked much with each other, and instead of taking this as alternatives, what we're advocating is really combining these two methods, combining the top-down method and linking it ideally really in a full end-to-end link between the two, find a path between these two worlds. So it's not just verification versus validification, but really the combination of both. And I think that's a very important area to go forward, and I'd love to talk more about that. I'm out of time, and thank you very much for your attention. If there's still a question, if we still have time for maybe one or two, I'm happy to answer them. Thank you.
Now, thank you, Philipp. Sorry to have pushed you a little bit, but you know there has been a lot of material this morning, and I think people really need a good coffee break, and they will be good, and also there will be more material before lunch. Yeah, I think still we have time for one or two questions. If not, I have questions, of course, but what about you? Well, okay, no, I don't see. So still, Mike, Philipp. So,
Everyone wants a cup of coffee, I guess. Now go ahead.
A few years ago, I think it was 2 or 3 years ago, there was a very nice, well, no, I wanted to ask you another question, in fact. Sorry, I changed. Right after the EC was publishing about Trustworthy AI, there were discussions in the networks about the matter. And then came the question, what do you, if you are looking for, let's say, a cancer diagnosis, what do you prefer? A system which is 90% correct and is proven for this 90%, and you have explanations, etc., or a system that is 99% correct but doesn't give any explanations, is not trustworthy? So there was really a question that was debated. What is your view on that?
I think this is a false dichotomy, right? It's not an either-or. It's the combination of both, like the diagram that I showed, right? Really pushing forward the functionality that AI systems can provide, the explainability and the control, right? Being able to provide guarantees about that. And we need to push in both directions, and essentially you can think about that as a Pareto front, right? Optimizing the possibilities as much as possible by combining both of those directions. I don't think this is really an alternative either or.